All right, let's talk digestion and the digestive system. Okay, so remember, there will be 40 questions just over this packet. I know it's only 12 slides, but there's a lot of organs and a lot of parts that we'll be looking at of the body in this lecture. We can group our organs of the digestive system into kind of two categories. Those that form what we call our gastrointestinal tract, GI tract for short, also known as alimentary canal, a continuous tube that runs from our mouth all the way out to the anus, which includes the mouth, the parts of the, not the whole, but parts of the pharynx, the esophagus, the stomach, our small intestine, and our large intestine. We've also got what we call accessory digestive organs, which do not perform any direct digestion or absorption, but do assist in the processes. This includes your teeth, your tongue, which are obviously in our mouth, salivary glands that we have in our mouth, as well as surrounding the oral cavity of our mouth, and then three majors, the liver, gallbladder, and the pancreas. Okay. So we'll be getting into all those throughout the lecture. We'll start at the top, working through the mouth, and then moving all the way down to the anus as we go. Our tract is approximately 5 to 7 meters, or 16.5 to 23 feet in length, and I have it listed there as in a living person. Obviously, 16.5 to 23 feet is much longer than we are tall. And if you look at the pictures at the bottom, you can see, especially in the intestinal area, especially the small intestines, there's a lot of twisting and turning, a lot of folding, front, back, side to side, which means that there's longer periods of time where that food is going to be in the body to be digested, and then the nutrients will be absorbed. Okay? And I say that it's in a living person in that length because actually after you pass away, the muscle that's in the walls of the tract relaxes, and then your tract will actually grow in length. Okay? Not that that's really that important, but your book talks a little bit about it, so I thought I'd mention it. Okay, embryologically, our tract forms from a tube-like structure and then develops outpouchings, and these outpouchings evolve into the attached digestive organs, including our pancreas, liver, gallbladder. There are storage, excretion, and detoxifying sites located along the length of the tract. We'll be talking about the entire tract, so we'll get into all that. When food is passing through the lumen or internal cavity of our GI tract, we consider it still outside the body. So if you had a granola bar when you first got to class, or you ate breakfast just before class, that food that's in your stomach right now is technically still outside your body. Not until we've broken that food down into very simple substances that can then be passed through the wall and into the blood or the lymph, then it becomes part of the body. Okay? So it's kind of weird in that sense. Our functions of the digestive system include the transportation of food and water and modifying our food and water to make them suitable for absorption and excretion. Okay, let's talk about the treatment processes of food in our digestive system. It all begins with the act of eating, a process of eating, what we call ingestion, which involves, the chewing and mixing up our food with saliva so we can swallow it. And swallowing is going to be an example of propulsion, movement of food along the GI tract, all the way from our mouth to the anus. Propulsion involves what we call peristalsis, a series of alternating contractions and relaxations of the smooth muscle that lines the walls of our digestive organs. A key with peristalsis, and I would highlight this, is it moves food forward only. And this is the major means of moving food through our tract. Okay. The difference between peristalsis and segmentation is that segmentation pushes food forward and backwards. Okay. And segmentation, as it shows it here, is a form of mechanical digestion. Okay. I always use an analogy here to explain this. And so I'll talk about squeezing toothpaste in a toothpaste tube. There's two ways to do it. The right way, like I like to do it, and the incorrect way, like my wife likes to do it. And these are arguments you get into when you get married. But I like to grab the toothpaste tube from the opposite end of the cap, and I always push it towards the cap by forcing the toothpaste always forward. I'm performing peristalsis. My lovely, beautiful wife will come in and grab that same toothpaste tube after I've done all that nice work and just squeeze it from wherever and negate all that work I did, shooting toothpaste out of the tube and also back towards the other end. She likes to perform segmentation. So it's kind of a stupid analogy, but hopefully it gives you a nice visualization of what the difference on peristalsis and segmentation are. Okay, secretion is the next thing I want to talk about. The production and release from a cell or gland of a physiologically active substance. This is what we do with saliva in our mouth, and that continues all the way through the rest of the tract with different chemicals. We'll be looking at a lot of chemicals. You know, that includes mucus and water and a lot of enzymes and bicarbonate and acid. So there's a lot of things that we release, something like 7 liters of chemical a day into the tract. And 7 liters is a lot of fluid. All right, let's talk about the 2 forms of digestion. Obviously, we do that. This is the digestive system. Mechanical digestion is a physical breakdown. Physical breakdown, I would highlight, that's a kind of cool, or that's not a cool, but it's an important term that is explaining what we're doing. We're taking a big piece of food and making it smaller. Okay, it's what we do when we, bite into our food. We're not like Shaggy and Scooby-Doo, where we can swallow a whole sandwich. We have to take bites out of it. We chew it up. We put it into smaller pieces. Okay. This continues with the muscular churning of our stomach, and that segmentation I was talking about, that pushes food forward and backwards. It's going to help chop it up into smaller pieces, which helps with chemical digestion, because the smaller the pieces we have, the easier and more contact the chemicals that we release come into the food and perform chemical reactions on those substances. Chemical digestion is a chemical breakdown. So we're talking about like breaking chemical bonds, performing a type of chemical reaction called a hydrolysis reaction. Stuff I don't really get into this class. But that's how we take our, things down to the very smallest level, performed by enzymes in our stomach and small intestine. Why we do that is so that we can absorb, which is the movement of molecules from the tract to our adjacent blood and lymphatic vessels, which is the whole reason why we ingest food. Our most basic drive to eat is probably because we're hungry or because we enjoy the taste of whatever it is. But really, the true reason we need to eat and drink is because we need to fuel our body with nutrients and water and minerals and vitamins that we don't produce on our own. Okay, so we're providing our body with the things it needs by bringing them in. Okay. Now, we don't absorb everything. Undigestible material, things that we just didn't have enough time to absorb, along with other stuff, is defecated out. And yes, we're talking about pooping at that point through the anus. Okay, looking at the figures, this is a cadaver version, looking at basically the lower abdomen from, you can see the diaphragm. So not really the chest, but more so the tummy area. You can see the big organs. Now, we'd have to remove a lot of them to really see all the parts. I can't even see really the pancreas here because the stomach's covering it up along with the intestines. Barely can see the gallbladder. We'll be looking at them all, various points in the lecture. Figure over here on the left basically has everything labeled. It's got the different parts of the small and large intestine all labeled out. Jejunum, ileum, duodenum are all parts of the small intestine. All the parts with the colon and the cecum, those are all part of the large intestine. We'll get into all that. I'm not going to worry about either of these pictures at this point. We've got better pictures to look at as we roll through. Now, before we move on into the different parts of our digestive system, which we'll start with the mouth here in just a couple slides, I want to talk about just the structure of the tract as a whole for a couple slides. This one and the next one. All right, so as previously mentioned, the GI tract is simply a complex tube from one end of the body to another, from our mouth to the anus. Our tract wall from our lower esophagus to the anal canal has the same basic four-layered arrangement of tissues. Okay, inner mucosa all the way out to the outer serosa. Now, the lower esophagus is not the beginning of the tract. Your mouth is. And then you've got the pharynx that we talked a little bit about last time. Does that mean your mouth and your pharynx and the upper and middle part of your esophagus don't have these layers? They just don't have all of those layers. And we'll talk a little bit about like how your, your mouth has some of them, not all of them. Okay. Let's talk about the mucosa. Just like we saw in the trachea that we talked about last time, the trachea was lined with a mucosa. So was our tract. So just like last time, might not be a bad idea. Keep your head straight. This is deep. This is superficial. So we're going from inside out with our rundown here. The mucosa of our digestive tract is a mucous membrane that lines it. And we find this in our mouth, as it says there, all the way down to the anus. There's 3 sublayers to the mucosa. The innermost layer is a thin layer of epithelium. Then there's a thicker connective tissue layer called lamina propria. And then there's a layer of smooth muscle called the muscularis mucosae. Okay. Functions of the mucosa. Probably pretty common sense, but we secrete mucus. But also other things, digestive enzymes, and hormones. Hormones are not going to be released into the lumen like mucus and digestive enzymes are. Instead, hormones that are released in our mucosa are going to be picked up by the blood. And just like all hormones are, for the most part, that we've talked about this semester. Our mucosa is very important for the absorption of the end products of digestion into the blood. And just very recently, we talked about mucosa-associated lymphoid tissue, which are lymphatic nodules like the Peyer's patches that you guys had to learn in our lymphatic lecture. This is where you would find them, okay, in that mucosa of our tract. And in this case, if we're talking Peyer's patches, that would be in the ileum of our small intestine. So there's protection against infectious diseases because of those mucosa-associated lymphatic or lymphoid tissues. All right, surrounding the mucosa is a submucosa shown here in white. The submucosa is made up of areolar connective tissue, a lot of blood vessels, lymphatic vessels, lymph nodes, and nerve fibers here, along with glands that connect to the lumen of that tract by having ducts that penetrate through the mucosa. Okay. Associated with our submucosa is what we call a submucosal plexus. The submucosal plexus is a network of neurons that controls the secretion of those glands of the submucosa. So it can trigger the release of digestive juices into the tract or shut it down. There's another plexus, but this plexus is associated with the muscularis, a layer of muscle in the tract, hence the name muscularis. What type of muscle and how much is dependent upon where you're at in the tract. Okay. In our mouth and our pharynx, we have skeletal muscle, important for the very beginning acts of swallowing. What do we know about skeletal muscle compared to smooth muscle, which is what you have the rest of the tract? Skeletal muscle works in a voluntary manner, which means that we have conscious control over it, and we can purposely swallow that food, pushing that food from our mouth into our throat. But do we have to control the rest of the movement of that food? No, because from there on out, it's all smooth muscle, which is involuntarily controlled. Our stomach has 3 layers of smooth muscle. It's the only one that has 3. The rest only has 2 layers. Okay. The small and large intestine included have 2 layers, an inner circular layer that runs around, and then a longitudinal that runs the length of the tract. Between them is that myenteric plexus, which is what controls the movement of those muscles. And then finally, the serosa is a serous membrane that lines the outside of the organs and is composed of areolar connective tissue with a layer of simple squamous epithelium surrounding it called mesothelium. Our serosa is also called a visceral peritoneum because it forms a portion of the peritoneum. Peritoneum is the 3rd of our serous membranes that was discussed in that very first lecture of the semester. And I said, hey, we will talk about these later on the semester. We talked about the pericardium, the parietal, the visceral pericardium here just last week. Talked just now today about the parietal and visceral pleura. Here we get to talk about the peritoneum. Our esophagus lacks a serosa. It only contains a single layer of areolar connective tissue called adventitia. Okay, as far as the picture, I do want you to highlight some stuff in it. So I will start at the top here, and I'll just go clockwise. Know the submucosal plexus. I'm not going to worry about the plexus of Meissner. I want you to know the myenteric plexus. Don't worry about plexus of Auerbach. So the 2 plexuses, the serosa and its 2 layers, the muscularis and its 2 layers, the submucosa, the mucosa and its 3 layers, and then I guess just lumen would be a good one to know too. Now, I can look at this picture and tell you right away that this is the small intestine. I can tell you actually it's the duodenum, and I won't explain why that is right now. But that's easy to identify that this is a small intestine for a couple of reasons. It's got 2 layers of smooth muscle, and it's not very wide. But more importantly, the easiest thing is it's got here labeled what we call a mesentery. We'll talk about that here on this page. All right, so let's talk about that peritoneum that I just mentioned. Here's part of the serosa. This is our largest serous membrane of the body. Consists of a layer of simple squamous epithelium called mesothelium with an underlying supporting layer of areolar connective tissue. What we just talked about with the serosa on the previous page is the peritoneum, or part of it anyway. We can divide the peritoneum into 2 divisions or 2 parts, just like we did with the pericardium, just like we did the pleura. The parietal peritoneum is what lines the abdominal pelvic cavity. It's the superficial membrane. The deeper membrane is called the visceral peritoneum, and it covers some of the organs in the cavity and is their serosa. Okay, between them is a slim space with lubricating serous fluid, and this is what we call peritoneal cavity. Most organs of the abdominal pelvic cavity lie within this cavity. Some are going to lie behind the cavity, covered by the peritoneum, only on their anterior surfaces, which means that they're actually not located within the peritoneal cavity. This includes the kidneys, which are not a digestive organ, but are a urinary organ that we'll talk about, into next week. Ascending and descending large intestine, the beginning of the small intestine, the duodenum, and then the pancreas. We call those organs retroperitoneal. That's a term that we described in that very first lecture of the semester. And I said at the time, we'll talk about them again in that term. Here we are talking about them. Unlike our pericardium and the pleura, which cover the heart and lungs, respectively, peritoneum has large folds that weave between the viscera or the organs, binding the organs to one another into the walls of our abdominal cavity. They contain blood vessels, lymphatic vessels, and nerves that supply those same abdominal organs. 5 major peritoneal folds include the largest, and it's kind of really gross looking, is the greater omentum. It looks like a yellowy, cottage cheesy grossness, and if we do dissect the cats, it's really gross pulling it out. It is just basically a bunch of fat. Okay, it drapes over the transverse colon. The transverse colon goes across the belly like that, and then it just drapes down like an apron. And it's a double sheet of membrane that folds back on itself. And as I said, it's fatty because it's got a lot of adipose tissue in it. And this is what can greatly expand with weight gain, giving rise to that characteristic beer belly, as people like to describe it. And it's shown down here in yellow. You lift it up, then you can see the organs underneath. With it here in our cadaver picture, we can't see the intestines because it's covering them all up. Okay. The next one is the falciform ligament. If I go back to this first page, the falciform ligament was labeled as a portion of the liver. It's actually going to separate the liver into 2 lobes. A left lobe and a right lobe. It doesn't separate the liver into equal lobes because your right liver is much bigger than your left liver. Okay, but the function of the falciform ligament, which is just this little connective tissue, just helps basically attach the liver to the anterior abdominal wall and the diaphragm. Okay, there's also a lesser omentum. The lesser omentum arises in the anterior fold in the cirrhosis of the stomach and duodenum, and suspends our stomach and the duodenum from the liver. It's this kind of white sheet that we show here. You'd have to lift up the liver. That's what's been done here to show it. Otherwise, you wouldn't really be able to see it very well. As I said on the previous page, I could tell that was the small intestine because the thing labeled was a mesentery, a fan-shaped fold of peritoneum binding the jejunum and the ileum, the second and third parts of the small intestine, to the posterior abdominal wall. Okay, and with the kind of small intestines kind of pulled out of the tummy, you can see the membrane known as the mesentery. There's also a mesocolon. Anytime you see the word colon, it's going to be a direct indicator that we're talking about the large intestine. This is 2 separate folds of the peritoneum binding the transverse colon and the sigmoid colon of our large intestine. Okay. This is a sagittal section. I didn't really point some stuff out into it, but you can see some of those folds. The lesser omentum is visible, the mesentery, the mesocolon are all labeled. I really only included it because it's in your textbook. And really, that's the only reason I included any of these. They're not things I'm going to have you worry about identifying. Pictures are not important on this page. We've got bigger fish to fry, as they say. So we'll move on from that for now. All right, now we can move from the top down with the track. Starting at the top, we have the mouth, where we have a lot to talk about. Okay. Other terms for mouth would be your oral cavity or buccal cavity. Really, I use mouth majority of the time, but I'll say oral cavity once in a while. Comprised of the following structures. First things I want to talk about are the lips. Other term for lips are labia. Labia is plural, labium is singular. Covered externally by skin and internally by mucous membranes. The junction between our skin and the mucous membranes is highly sensitive. Our lips assist with eating and forming sounds. Down at the bottom, we have a wide open mouth with the lips kind of pulled upward and for the upper lip and then downward for the lower lip, showing that there's two pieces of tissue that kind of help attach our lips to our gum line, a superior labial frenulum and an inferior labial frenulum. If you put your tongue in that space above and below, you know, in front of your teeth, you can feel that little tissue, okay? This is a midline fold of mucous membrane, okay? Your cheeks are the lateral boundaries of your oral cavity and are continuous through the lips, also on the inside lined by mucous membrane. That space that I just mentioned where you could put your tongue or where somebody would put like a wad of tobacco is called the oral vestibule. It's bounded externally by your cheeks and lips, internally by your gums and teeth. So it's this big space we've got on the top and then on the bottom. Okay. Vestibule is what it's labeled as down there. Here I have it listed as oral vestibule. Same thing. The oral cavity proper is the space extending from our gums and the teeth to the fauces. The fauces, remember, is the space at the back of our mouth that leads to our oropharynx. So from your teeth back to that little dangling down uvula is basically that oral cavity proper. So it's all of this area where you have your tongue, essentially. Okay. Already mentioned the fauces, opening between the oral cavity and the oropharynx or your throat. Your hard palate, comprised of 4 bones, 2 maxilla, 2 palatines, forms the kind of anterior 2/3 of the roof of your mouth. The back third is from the soft palate, which is made up of muscle, skeletal muscle, specifically arranged in an arch structure. There are 2 arches I want to talk about associated with your soft palate, the palatoglossal arch, which is anterior, and then a palatopharyngeal arch, which is posterior. And they're labeled here. They're kind of tough to tell apart, but the more posterior is the pharyngeal, the glossal is more anterior. I already mentioned the uvula. That's a structure hanging down from the rear of the soft palate, which rises during swallowing, closing off our nose from food intake. Thing that looks like a little punching bag. Okay. And then the tongue, something we've talked a little bit about before, a solid mass of skeletal muscle covered on the outside by a mucous membrane. Helps with positioning food during mastication, which is just a fancy word for chewing, by gathering our chewed food up into a bolus, which is a ball that we swallow. It also helps with forming words. So your tongue itself is a muscle, and then attached to it are what we call extrinsic muscles. Those were listed in that lecture on the muscles. I told you not to worry about them at the time, but they help attach to the skull and neck and move our tongue side to side and in and out. Intrinsic muscles originate and insert into the connective tissue within the tongue, help alter the shape of the tongue for swallowing and speech, and those are the things that like enable you to like roll your tongue if you can do that. On the bottom of the tongue, and we can only see it here because the tongue's been lifted upward, is a lingual frenulum. The lingual frenulum is like the labial frenulum in that it attaches, in this case, the tongue to the floor of the mouth. Not visible, but very tiny structures within the tongue are lingual glands within its lamina propria, secreting both mucus and a watery serous fluid containing an enzyme called lingual lipase. A little bit of the word lingual looks like got cut off. There's a G there. But this helps with digesting fats. And our tongue itself consists of a root body and tip, which we've seen before. Okay, make sure you highlight everything in this picture. There are very important structures that I did not talk about that are part of our mouth. What didn't I talk about yet? That you see here, your pearly white teeth. We will start with talking teeth on Friday. Make sure you know everything. Oh, I guess did I miss? No, gingiva will be on the next page. Yeah. Everything, which includes the teeth that I haven't talked about, will be fair game. Palatine tonsils we've talked about before. I want you to know those. An important picture. Okay, I will see you guys on Friday. No lab today.